Hello, good evening sa inyong lahat. And tonight is another review for Registered Master Plumber. And this is continuations dun pa sa mga previous live natin. At previous lives natin, I tackled already the different pipings, fittings, and also the definitions na kailangan natin malaman when it comes to there's a problem, glitches sa aking internet, so I have to time to time baka mawala ako. So anyways, I will discuss now. Okay, discuss natin yung I don't know kung naririnig ako. I think naririnig naman ako. So check muna. Okay. I will discuss now the chapter 7. Yan. So, nawawala ako, kaya pa-wait na lang. Okay, if you're not yet following my page, kindly follow my page and like my videos para naman po updated kayo kung sakaling magla-live ako, meron naman akong ibang ituturo ngayon. So, this time, I will share with you the content of our lecture. This is the basic plumbing tools for drainage pipes and fittings. So, kailangan natin itong malaman para at least we are aware of the materials na gagamitin natin pagdating sa master plumbing. Okay, so if you can hear me, just comment, and if you hear me, just say yes. So, Hayan, thank you so much for our viewers there. So, let's start. Okay? So, the basic plumbing tools for drainage pipes and fittings. So, ano ba yung mga kailangan natin alamin, tandaan, pagdating sa mga fittings nito? Okay, so here are the common tools used in the drainage pipes and fittings. We have the hacksaw, closet auger, plunger, rule, torch, lead pot, or pouring ladle, joint runner, ball peen, ball peen, hammer, hindi siya ball pen, ball peen, hammer, cold chisel, caulking iron, soldering copper, tin snip, plumb bob, and plumb level on the file. Okay, so etong rule or the push-pull tape sa mga kailangan natin na gamit. Okay? This is to measure the pipes. So, that's all we need, diba? This is to measure the pipes, to be cut, and for measure the run of the pipes. And as well as we use the push-pull tape para ma-measure din natin yung location. Kasi, syempre, we cannot estimate the measures of the pipes if we don't know the measures of the location. Next is the blowtorch. Blowtorch this is used as a source of heat when melting lead and heating the soldering copper for coke joint. Okay, that's this blowtorch. Next is the hacksaw. So hacksaw, this is used for cutting pipes. And we have also the lead pot. This is used as a vessel for holding lead to the melted. This is also known as melting pot. We have also the pouring ladle, and this is used for scooping up melted lead to be poured into cast iron soil pipes to make a caulk joint. Usually, we use the lead pot pouring ladle dun sa mga cast iron pipes natin para sa mga dugtungan. Okay, we have also the closet auger. Ayan. So we have the closet auger, and this is used for removing clogs. And in the drain pipes, usually water closet, urinal, and the lavatory stoppage. You have also the joint runner, and this is used to close the gap between the hub and the spigot of a cast iron soil pipe while molten lead is poured into the joint of a horizontal pipe run. This is also known as the pouring rope. We have also the ball peen hammer. So this is the ball peen. Tawag po dito ball peen. Okay? Tandaan nyo na lang po yung ball pen. So this is used for caulking. We have also the gold chisel, and this is used for cutting cast pipe iron and for boring holes. Gold chisel po yun. Next, we have also the plunger. So, plunger, pambomba, tinatawag natin bomba, di ba? So, this is used to clear the trap of the floor drains or minor obstructions through a pumping action. This is also known as plumber's friend and plumber's helper. Okay, so usually we use the the pressures. Kaya, 'di ba, since inaano natin diyan, pinapump natin yung water, then yung pressure na apply kaya yung tendency is bababa talaga siya. Yung clog nawawala. Okay, we have also the caulking iron, and this is used for caulking occum and lead for bed and spigot joints. We have also the tin snip. Tin snip, this is used for cutting GI. Yung mga GI sheets natin for straps to anchor pipes. So next is file. File is this is used to remove the burrs of cut pipes. And we have also the soldering copper. So this soldering of copper is used for soldering lead on flashing of vent pipes on GI roofing. We have also the plumb level. Ile-level natin. This is used to establish the grades on horizontal drains pipe runs. And of course, yung plumb bob, and this is used for establishing vertical runs for pipes. So that's for 7. And now, let's proceed to chapter 8. This is the water supply sources. Mm, okay. So here's the water supply sources. So providing water in buildings is one of the most critical utility requirements. A building without water supply is unfit for human habitation. So generally speaking, potable water is supplied from a local utility through a public water system. So for buildings without public water system, an alternative source of water must be considered, yung such as springs, the wells, and the rainwater. Now, so spring water source, yung mga tinatawag nating bukal, 'di ba? In most conditions, springs are shallow wells and with water supply just a few meters from the ground surface. If this is the source of domestic water, so careful attention must be given to yield and purify. The flow may stop during dry season, or surface water may be contaminated. So spring water can be developed so as secure maximum protection from contamination by excavating sufficiently to locate the true spring openings and to ensure a secure foundation for the encasing structure. So this structure, we call that spring box. So which is served as collector for spring water. So water collected from the spring box flows to a larger storage tank and then to the distribution pipes. So so the determination of the yield of the spring water source implies a very simple procedure. So they are as follows. So first is channel the flow for the spring into a collection basin. Make sure that the basin collects all available flow. And number two, place an overflow pipe through the dam so that the collected water flows freely through the pipe, and there should be no leakage around the pipe. Number three, put a bucket of known volume, for example, a 10-liter bucket, under the overflow pipe to catch the flow. Okay? Four, with a watch, measure the amount of time it takes to fill the bucket. At this instance, the rate of flow can be determined. And five, check the rate of flow per day. If it is sufficient to supply the daily water demand of the occupants. So that's how we determine the yield of the spring water source. First, you need to channel the flow. You need to know kung nasaan. Tapos collect mo sa basin. And number two, place an overflow pipe through the dam so that collected water flows freely through the pipe. And put the bucket and etc. until you check if it is the rate of flow per day. So here's the sample problem or determination of the spring yield. So example, it takes 60 seconds. So this is the time plus and to fill the 10-liter bucket. So 10 liters the volume. Sulatan natin. So this is the what we call time T and interval that is V. So determine if the daily yield is sufficient to water demand of the community. And we have here 200 people, the capacity. Person is 60 liters. So daily consumption daw ng kada tao ay 60 liters. So how we will able to identify the daily yield sufficient? So first is rate of flow. We need to get first the rate of flow. So rate of flow, so susulatan natin dito. So here is the rate of flow. R is yan. Rate of flow, yan, is equivalent to volume over time. Okay? So that's why we get the 10 over 60 liter per second is that is 0.16 liters per second. So this time, we need to determine the yield. Sorry. We need to determine the daily yield. So how we can know the daily yield? So the daily yield is so the daily yield, yeah, ganito na lang. So hanap tayo ng, so the daily yield, Y, D, which is daily yield, is equivalent to, of course, 0.16, this is the rate, flow rate, right? And so this is the flow rate. Then, times kung ilan yung time. Okay, yung day na ginagamit natin. So, that is 0.16 per second. So, gagawin natin siya per day. Kaya, yung daily yield natin is time meter per second times that is 60 seconds 1 minute. Kaya nga, makakancel natin to. Tapos, 1 minute, kailangan daw is per day. So, alisin natin yung R. Kaya, magkakaroon tayo ng sagot na 13,824 liters per day. Okay? Now, so ano naman ang total daily demand, daily water demand? So, how we will able? So, total daily demand is equivalent to 200, so yung per person, which is kung ilan yung per person, times yung kanina na nasagutan natin, that is the 60 liters per person per day. Okay. Yung kanina itong given na to, ito. So, that is the consumption. Sabihin natin C, no? Consumption. 60 liters per day, per person per day, that is 60. So, the total daily water demand is equivalent to, so ayusin ko lang to, T is equals to P times C. Yan, para maayos. So, make sure, pagka ganito yung problem, tatandaan na lang po natin. So, therefore, the spring with the daily flow is of 13,824 liters still sufficiently meet the demand of the community of people. So, ito tatandaan din natin to. Y is equals to R times P. Yan. Para natatandaan natin. Tapos ito naman, yung R is equals to the volume per over T. Yan. Tapos erase natin ito. Para clear. Maganda siya tingnan. Yan. Okay? So, tatandaan lang po natin yan. Ngayon, let's go to well. So, well, ito yung balon. No? Kung kanina yung spring is bukal, ito naman balon. So, yung balon, where are the holes or shanks sunk into the earth to obtain the water from the aquifer? So, what is aquifer? An aquifer is a water-bearing formation of gravel, permeable rock, or sand that is capable of providing water in usable quantities to springs or wells. So, the design and proper construction of a well require scientific knowledge of hydrogeology, common sense, and practical experience. So the types of wells generally refer to the methods of its construction, which are dub, bored, driven, drilled. So sa drilled, we have the percussion, rotary, and reverse circulation, rotary, and jetting. So first is dug wells. So, dug wells, these are 60, tandaan natin, these are 60 millimeters, centimeters, or more in diameter dug through the soft upper soil. So, the sides may be masonry or concrete to prevent from caving in. Ibig sabihin yung parang matabunan ulit yung kinalot or yung hinukay, di ba? It is necessary that the well should be impervious to a depth at least of 3 meters. So that's the depth, at least 3 meters. Next is the bored wells. Bored wells, these are constructed using either hand or power-driven earth auger, and a well casing is lowered to the bottom of the hole. After the boring is complete, cement ground is poured to fill the gap between the bored hole and the well casing. So this is to prevent contamination. Next is what we have is the driven wells. So the driven well is done by forcing into the earth a 60 to 90 this is 60 to 90 centimeter long piece of perforated steel tube attached to a pointed screen called a drive point. So this type of wells varies from 32 millimeter diameter, and the depth of this is 3 to 12 millimeters. So we have also the drilled wells. So usually we use the wells or yung mga din-drill natin kapag yung mga sa yung geothermal, okay? Mga geothermal plants. So, a drilling rig is used to drill the well hole, and then casing or tubular pipe is forced down the hole to prevent it from caving in. So, when a water-bearing stratum of sufficient capacity is found, a well screen is set in place to permit the water to flow into the casing and to hold back the fine material. So, the depth of the well is limited only by distance. One must dig to obtain adequate supply of fresh water, even to the pinakamalalim, it's 450 meters. Okay, so that's for the well. Now, let's go to the rainwater source. Ayan. So, sa rainwater source, in terms of resource conservation, rainwater is an attractive alternative. So, rainwater is soft and is near to the purest state in the hydrological cycle. So, however, air pollution causes rainwater to be acidic, which corrode non-ferrous pipes and cause rusting and clogging the steel pipes. In spite of this condition, rainwater collection system remains a viable water source alternative. We can use this actually sa pag-gardening, di ba? And this system typically employ a cistern, a covered reservoir tanks to store water collected from roofs or other relatively screened impervious surfaces. So the collected rain can be used for flushing the water closets and urinals as well as for landscapes purposes wherein potable water is not necessary. So, the City Council of Cebu promulgated City Ordinance number 1711. So, tingnan natin tong sample na to. And otherwise, as known as the Water Conservations of and Flood Ordinance. So this ordinance requires all the projects to provide a permanent water tank or container proportionate to the roof area. And these are the follows. So for in commercial, industrial, and institutional, kailangan ng 1 cubic of meter tank container for every 15 square meters of roof area deck up to maximum 7 cubic meters. So for residential buildings, it's 500,000 pesos and above cost. So kailangan ng 1 cubic meter of tank container for every 15 square. So 15 square meters of roof area or that to maximum of the 3 cubic meters. So for the sizing of the rainwater cistern, so these are the two methods can be used to determine the size of the storage tank. We have the use of Cebu City Ordinance 1711, which states that for every 15 square meter, 1 cubic meter of rainwater can be collected. So this is the short method of sizing the cistern. And the use of the rainwater fall data of the locally, this is long method of determining the size of the cistern. So we have sample problem number 1 and sizing of rainwater cistern by local rainfall data. So as part of the design problem, this is just a sample ha. So as part of the design problem, it was required that 5 water closets, meron tayong 2 urinals and 2 slop sinks of a school building in Cebu City can be provided with an alternative source of water supply, specifically from rainfall catchment. So you are to determine the size of rainwater system based on the following given assumptions. First is the water closet shall be flush tank types. 2. Rainfall data of Cebu is available from Pagasa. 3. Roof area is 1,000 square meter. 4 is capacity of cistern to satisfy 30 minutes duration of water demand. And 5 is rainfall catchment efficiency is 80%. So we have here that this is water closets and in flush tank types. Meron tayong rainwater data is of Cebu roof area is 1,000 square meter and capacity of non-cistern satisfies 30 minutes during duration of water demand. So here to solve the rainwater demand load, first is we have here water closet and water closet that is 5 times 5 WSFU that is 25. Urinal is 2 by 5 that is 10. Slap sink 2 by 10, that's 20, overall 55 WSFU. So from tables and bulbs, the equivalent for 55 W is 929 GPM. So kailangan meron tayong meron po tayong table for that. So the estimated daily demand is 29 gallons per minutes times the 30 minutes para ma-remove natin tong ayan. So, estimated is nasa 870 gallons. So, the estimated annual demand is equals to 870 gallons per day times 365 days kasi 1 year and is equivalent to 317,550 gallons. So, or meron tayong 1.2 million na liters. So, the estimated average monthly demand is 1.2 liters per year, no, per 12 months. So, or, um, 12 months is 100,000 100.16 cubic meters, gano'n. So, determining the rainfall water from Pag-asa, ito yun. Meron tayong number 2 question. Determining the rainfall, we have the January, February, March up to June, at ito yung mga rainfall niya. So, the average rainfall, kapag in-add natin ito lahat, is 1,628.70. Okay, so now, we need to solve the amount of available rainwater per month. Available rainwater per month, monthly rainfall times, ito po yung formula. Available rainwater is equals to monthly rainfall times roof area times 80%. So, if that, per natin, the total is 1.3 liters. Okay? So, the average monthly supply is nasa 1.3 liters over 12, that is 108,580 monthly. So, add the available rainwater cumulatively. I-add natin sila. So, and that's it. So, here's the sample of the isometric view of the rainwater na ano natin. Ito yung collection, ito yung filter box, diba? So, ko na masyado, i-share ko na lang to sa inyo. So, here's the details of the typical spring box. Okay? This is the lowest spring, tapos kinukuha, tapos mayroong filter, tapos collection box. Pagdag ng well, ito po yun. 'Di ba? Nasa 3 meter lang yan. Tapos ito po yung pag-drill, no? Sa drilling. Drilled well, ito po yun, gumagamit na po tayo ng pang-drilling materials. Yan. Drilled well by jetting, ito po yun, sample. Typical details of rainwater cistern, ito naman po sa rainwater cistern. Usually, what we have here is meron tayong downspout, tapos collection box, then drain pipe, and etc. So that's it for tonight, and thank you so much for watching our video. And by tomorrow, chapter 9 naman to, domestic cold water supply. So thank you so much for joining my video tonight. Thank you so much, Arlette. And please share, follow and share this video. And you can watch anytime yung mga videos natin. So basta i-follow nyo lang at panoorin nyo lang po yung mga ating review dito sa page na to, Engineer Joy Mandane-Ortiz. And dun nyo lang po talaga makikita yung ano po, yung mga review materials natin. Just follow, and kung gusto niyo ng review materials, follow niyo lang, screenshot niyo, send niyo sa akin, then bibigyan ko kayo ng access for the review materials. Okay, that's it. Thank you so much. God bless you.